Imagine a black hole approaching our solar system. Instead of a giant vacuum cleaner, think of an incredibly dense object with immense gravity. As the black hole nears our sun, its gravitational pull would be the first sign of its presence. This pull wouldn't be a sudden jerk but a gradual increase in the sun's movement. The black hole's gravity is far stronger due to its incredible density. This difference in gravitational strength would create a tug of war. The black hole would begin to pull material from the sun's outer layers. This material wouldn't fall directly into the black hole but would orbit it, creating a swirling disk. The distance between the sun and the black hole would determine how quickly these effects would be felt. However, the presence of a black hole so close to our solar system would inevitably spell doom for our sun and the planets that orbit it. The question isn't if, but when, the catastrophic events would unfold. Black holes demonstrate the immense power of gravity and the mind-boggling phenomena that can occur in the cosmos. While the idea of a black hole consuming our sun is a distant hypothetical scenario, it serves as a reminder of the forces at play in the universe. As the black hole draws closer, its pull on the sun's material intensifies. This material forms a swirling disk around the black hole, known as an accretion disk. Think of it like water circling a drain, but on a cosmic scale. Friction causes the material in the disk to heat up, reaching millions of degrees Celsius. This intense heat causes the material to glow brightly, emitting X-rays and gamma rays. These emissions would be the first sign to distant observers that something is amiss in our solar system. The once dark region of space where our sun resided would now shine with an eerie, energetic light. The accretion disk isn't a static structure, it's a dynamic and chaotic environment. Material constantly falls inward towards the black hole, while other material is flung outwards. Magnetic fields thread through the disk, creating powerful jets of energy that blast out from the black hole's poles. The formation of the accretion disk marks a turning point in this cosmic encounter, signaling the beginning of the end for our star. As the black hole devours more of the sun's mass, its gravitational pull on the remaining solar material becomes even stronger. The side facing the black hole experiences a much stronger pull than the side facing away. This difference in gravitational force leads to a phenomenon known as spaghettification. Imagine a ball of dough being stretched. As it's pulled, it becomes longer and thinner. The sun, under the influence of the black hole's gravity, would begin to stretch. The side facing the black hole would bulge outwards, while the opposite side would remain relatively unchanged. The sun's internal structure would be ripped apart as its own gravity struggles to hold it together. This internal turmoil would release massive amounts of energy, resulting in powerful solar flares and coronal mass ejections. Earth, if it still exists at this point, would be bombarded with radiation. Spaghettification demonstrates that even objects as massive as our sun are insignificant compared to the immense gravitational forces at play. The sun's fate is sealed. As the black hole continues to consume its mass, the sun will shrink, becoming denser and hotter. Eventually it will reach a point where it can no longer sustain nuclear fusion, the process that powers stars. At this point, the sun will effectively cease to exist as a star. Without the sun's gravity to hold them in their orbits, the planets will be flung outwards like stones from a slingshot. Some planets might collide, creating spectacular, albeit catastrophic events. Others might be ejected from the solar system entirely, doomed to wander the interstellar void. The destruction of the sun would be a cataclysmic event, felt across the galaxy. The once bright star would vanish, leaving behind a void in the fabric of space-time. The solar system, once teeming with life and potential, would be reduced to a scattering of celestial debris. While the fate of the sun and the solar system is bleak, what about Earth? Unfortunately, our planet's prospects are equally grim. Even if Earth somehow survives the initial chaos of the black hole's arrival, it will eventually succumb to the same fate as everything else in the solar system. Without the sun's energy, Earth would rapidly cool, the oceans would freeze, the atmosphere would condense, and the planet would become a barren, icy wasteland. Life as we know it would be impossible. There is a slim chance that Earth could be ejected from the solar system intact. However, even in this unlikely scenario, the planet would be a rogue world, adrift in the vast emptiness of interstellar space. Without a star to provide warmth and light, life on Earth would face an uncertain and ultimately unsustainable future. The hypothetical scenario of a black hole consuming our sun is a stark reminder of the fragility of life and the immense power of the universe.